Hello, hello everyone. I hope you are doing great so far. I'm really happy to be here at this Council University. And today I want to talk about two topics that EDR vendors usually don't like very much. That is EDR bypass and HTML smuggling. And just to be clear from the beginning, this is not about how to be a criminal. This is about to understand how modern attacks really work, and so we can build better defense and better labs. And so who am I? I am cybersecurity researcher at R19.io. I focus on EDR evasion and offensive security. I spend a lot of time in malware labs, doing deep diving, researching and break things. I really enjoy go under the hood, syscalls, loaders, all the low-level stuffs. And it sometimes sounds boring at the first time, but it becomes a lot of more fun when you use it to pop a shell. He is basically is the wall of my certifications for NICE Council. The idea this slide is not to the brag, it's just to show that I've spent an unhealthy number of hours breaking labs and exams from more defensive paths to very offensive security focused on like spent style content. All of this shaped it's how I think about lab design and realistic scenarios, which is exactly the mindset behind the talk. Okay, so let's get started. He is basically the plan for today. First, a quick HTML smuggling recap, um, just enough so everyone stay in the same page. Then we'll dive into syscalls, direct and indirect, and what that actually means. And after that, we'll put everything together in a full chain from the inbox to the memory execution. And we'll wrap up with the vendor's perspective and a quick quiz to see what is stuck. And why does any of this matter in this real world? First, because EDR is basically everywhere in modern environments. Okay, even small companies have some kind of protections. And second, attackers are moving towards stealthy and memory techniques to avoid classic detections, not obvious XE on disk. They try to fewer noise API calls, more focus on memory and syscalls. So this is like the cat and mouse game. Defenders add more hooks and telemetry, and attackers move on a layer deep into the system. This diagram sums it nicely. This at this endpoint where don't just have a good and bad. We have here a mess of mix. No malware, new malware, 0 days, unique custom tools, and compromised legitimate all living together. The more targets that attack, the more it look like the top right area custom or modified tools that blend with legitimate activity. That's where HTML smuggling and Syscall tricks really shine. Okay. Okay, so let's start with HTML smuggling, as Microsoft described in their blog post. Instead of sending a binary payload directly, the attacker send HTML or JavaScript file, maybe as an email attachment or a link sometimes, and the user open it in the browser, and the browser itself reconstruct the payload on victim machine. And so we go literally from inbox to the memory. And I have a question, but I know that you cannot okay answer this question right now. But when the browser is on building the firewall locally, which network level defense are blind. Think on, let's say, emails, gateways, proxies, attachment scanners, thinking about that. And let's try to summarize here the HTML smuggling in 30 seconds. And basically the browser builds the payload locally using JavaScript. The real file never crosses some network filters as a normal attachment. That's great because for delivering in-memory loaders that you do not have work later. So instead of throwing a suspicious exe at target, we throw a suspicious index.ml. Somehow that feels less scary to many filters, let's say. This diagram, okay, it's another diagram show a more realistic chain where we start with a spear phishing that contains a link that the users click it, the HTML smuggling techniques drop a zip file, and that zip file basically contains the JavaScript file downloader. The JavaScript then contacts the malicious site, downloads another zip file with DLLs, and eventually loads a malicious DLL via DLL side loading. Sometimes you can use another techniques, of course, which can then to do things like theft credentials or keylog. Okay, notice how many steps happen after the initial HTML and how many of them are controlled by attacker. Now we zoom into the core of this talk, going from HTML into shellcode. In the end of this, look like this. The HTML delivers the loader. Okay, the loader executes in user mode, of course, because sometimes you don't have, usually in businesses, you don't have privileges to execute them, and then you start with user mode. The loader allocate, inject, and execute the shellcode, usually it's in our process or in a remote process. HTML smuggling, just to clarify, is just like a delivery guy, the one breaking into the house, okay? And let's go to the black screen. On this slide, you can see a time pass of shellcode in disassembly shellcode from the form. Okay, it's going things like cleaning register, preparing arguments, and at the end executing syscalls to cross to the kernel mode. And this can be reconstructed and delivered as the least step of HTML-based chain. But you don't have to read you don't have to read every instruction on the screen during the talk. The point here is to show that we end up directly at the CPU level, not just at API level or high-level APIs. Now we officially enter in syscalls. Okay, this diagram shows the classic protection rings, and you can see application on the outside, drivers and the kernel close to the sentry. As we move WinYard, privilege increase, of course. Our loaders live in ring 3 user mode. Remember that our loader live in ring 3. When they want to do something powerful, basically create a process, alloc memory with a special permission, they have to ask ring 0 to the kernel for help. Basically this help is, okay, that asking for help is exactly what is syscall. Okay, let's define it clearly. We have basically a separation between user mode, that ring 3, and kernel mode, ring 0. A syscall is basically a request for a service from the kernel that open a file, unlock memory, map a section, etc. On x64 DCP instruction that basically perform this transition, it's literally called syscall. So every time your code needs something privileged, has to ring the doorbell. And of course, stack pointers and shellcode loaders don't always agree on how to do nicely. And to include at least one meme here to remind us that when we start playing with indirect call stacks and stack pointers get very sensitive. So when you are hacking around with this stuff, your program crashes for not obvious reason. It's probably the stack screaming at you. Backing to something a bit more structured, let's say the classic Windows call flow. In normal program, calls a function from kernel 32 or ADVPI, which then calls into NTDLL. And from there, we reach the syscall stub and finally Windows kernel. And let's say EDRs love this area. They hook in API functions and sometimes patent TDLL to inspect arguments, get their telemetry, or even block calls. So if you are trying bypass user mode hooks, where is this chain you do try to cut? That is questions that syscalls try to answer. That's really interesting. Okay, and this introduce direct syscalls. I'm trying here to show the difference between direct and indirect syscalls. But right now, this can appear a little bit boring, but wait, we have a lab after that, and I will show how to exploit that. Okay, and this idea is to skip the noise user mode layer where most hooks lives. Instead of asking kernel 32 nicely recraft our own little function that goes straight to the syscall stub with the correct number and arguments. In this screenshot, you can see basically how we jump from higher level functions down to lower level syscall interface. And this is another meme, and basically the attitude behind direct syscalls is, look me, I'm compiler now. And basically with direct syscall, we stop trusting Windows to generate the right stub for us to start to generate our own transition to the kernel. But we have a problem here, of course, as well see, the kernel and ADR are not stopped. Okay, they eventually note this behavior here, and basically you can see the clear mental model with direct syscall weird. Basically, these steps that's really you can understand more after that. But basically here we skip WinAPI and call the syscall stuff directly. Set the registers ourselves and execute syscall. And the goal is basically to evade user mode hooks that live in those high-level libraries. In this diagram, you can see the programs talking almost straight to NTDLL and then to the kernel bypass the user wrappers. And of course, like I said before, directly syscalls come with problems. Syscalls number change across Windows versions, so hard coding then it's fragile. How can you see Windows 10, Windows 7, Windows 11? You have a lot of versions, and then these numbers can be changed. So word calls tags that jump straight into syscall stand out because normal apps almost never do that. EDR can scan memory for custom syscall stubs or look for unusual transitions into the kernel. So directory syscalls helped for a while, but they also became a pattern you hunt for, okay? And then sometimes this doesn't work well. And so we needed to be sneaker, and that's we are indirect syscall comes in. The idea here is to use the kernel without being loud. Instead of our process suspicion stubbing calling syscall, we try to reuse the legitimate stub inside an TDLL or some get that already ends in syscall. It's like saying, I'm not going to be the door. I'm going to slip through a door that's already there. So summarizing the concept, okay, we use legitimate stubs from NTDLL instead of our own custom trampolines. And then we reach the syscall instructions indirectly, often via a chained get that ends in syscall. And the call stacks look much closer to a normal flow because this is passed through NTDLLs like a regular web. From EDR point of view, this is significantly harder to distinguish from the normal behavior. And as you can see here, you can see both models side by side. And let's start with directly, and we start with loader, custom stub, syscall to kernel, and indirectly basically go through loader, legit stub, get in TDLL, and syscall to kernel, and basically directly create a very recognizable pattern, some random region of memory suddenly calling syscall, and indirectly tries to look like a normal app using NTDLL. This is the mental image I want to keep after the talk. Directly, directly my own private door to the kernel. Indirect, I basically sneaking through the existing official door. Now, let's put everything together into the full stack. First, remember, HTML delivers the loader via browser. That's basically it's our smuggling phase. Then the loader uses indirect syscall for memory operations, and these memory operations, it means allocate, write, change permissions, and finally the shellcode executes only in memory, often leaving very little on the disk. So we go from just HTML file to the kernel level functionality with a minimal class indicators. All right, time right now, it's time to the best part, the live demo. What you see is basically an HTML page reconstructing the loader locally. The loader you perform memory operations using indirect syscall, and finally a reverse shell payloader firing from the memory. This is pretty much how we basically all you feel when the demo actually works, and the pure hack energy. And the jokes aside, the point of the demo is that show this is not just theory. These patterns are real, and they exist today in offensive tooling and sometimes in real attacks. Okay, let me share my another screen. I recorded a short video to demonstrate that because my time it's really close. Let me share something else here. Okay, let's share here. That's okay for all. So I'll see my screen, my new screen. Please, Shupa, can you confirm that? That's okay for another screen? I think so. Okay, so let's get started. And basically here, in the first time, I'm showing my Microsoft Defender, my XDR from Microsoft Defender, and I'm show all steps to bypass this EDR using indirect syscalls. Okay, let me put play on. Okay, and the first time I'm showing basically the host name of my machine that's called recycle. Okay, let me show that this recycle this already have an incident that was disclosure, and I just put here one ACAR file just to demonstrate that my XDR are working well. Okay, and all the protections are enabled, okay, and updated. Okay, let me show right now my attacker machine. This example was demonstrated in recently on besides, and basically here I'm creating my reverse shell in a hex file, okay, to use inside my my payload. Okay, I'm trying to show you here my IP address, the IP address from attacker. Okay, and this output that I generated from my MSF panel, I'm using to create my my payload. Okay, and basically here I constructing my payload file, and I will compile now using the Go language. Okay, I'm using here the Go language to compile this syscall. Okay, I already created the directing syscall, and basically the next steps right now it's to basically to transform my executable to base 64 to put inside of my HTML Smuggling. Okay, and basically converted my XZ to HTML Smuggling file. Okay, and I basically here put my my payload inside from my HTML Smuggling. Okay, these codes are available on my GitHub. And then I can share this my all steps and my GitHub after that. Just ask me in my LinkedIn page. And then here I'm adjusting buttons on together. I basically open one web server to provide my web server, and right now I am I'm building my listening. Okay, and remember, all the information how to reproduce this are available on my LinkedIn page and my YouTube channel, and as well in my GitHub. Okay. That's really the normal process. I already created my exploit, and right now I'm setting my handle. Okay. I already have my environment ready to start the exploitation. Okay, and I will access the page, and look that when I just access the site, and in the same time the loader was downloaded without interaction from the user. Okay, and observe that when I execute my payload that was created, I received my shell. Okay, I received my shell and I bypassed the Windows XDR Defender. Okay, you can use this with another EDR, of course. Sometimes you need to change your payload or try to use another type of encoding. But how can you see this exploitation not was detected? Okay, the last detection was my ACAR file. That's just a test file. Okay, and I don't have any suspicious since my last test. Okay, that's it. It was my let's go back to presentation. Okay, just confirm that if you can see my screen again. Probably that's okay. Okay, now, let's talk about how Blue Team can hunt this. First, watch abnormal calls, stacks, and RWX memory regions. Code execution from memory that was just made, read, write, execute is rarely innocent. Second, correlate browser, file, new process. If an HTML from internet leads directly to doing process, trained memory actions, or network beacons, that is a strong signal. Third, make to use HTW, but just a point here. HTW this is another level of protection, but we already that's already have ways to bypass HTW, but you can use HTW to improve your defense. Okay, you can use sysmons and behavior focus on analytics, not just sample block dysfunctionality. Okay, and all right, a quick quiz to see how much survived here to the MEMS. The first question is, what does HTML smuggling bypass first? Okay, I know that many people can answer that, but network filters, kernel mitigations, or BIOS. Yes, basically the mainly here is network mail filters by building the file locally. This was the first steps. The second question is, what are direct syscalls mainly used for? Okay, and here let me answer as well, is to bypass user mode API hooks by calling syscall stubs directly. I'm just input your mind all the time this information. The third question is, what do indirect syscall try to look like? This probably it's easy after you see my labs. They try to look legitimate calls going through NTDLL with normal looking calls stacks. Quiz, actually, it's a good way to see if the main ideas landed HTML smuggling for delivery directly and indirect syscalls for execution and behavior-based defense. And let's wrap up everything. HTML Smuggling give us stealthy browser-based delivery that sidesteps some network defense. Indirect syscall give us more legitimate hooking access to kernel, make it harder for EDR to rely on simple hooks. From a defensive angle, behavior and correlation across browsers, process, memory, and networking are far more robust than just looking at API names or signatures. If there's one message I want that to live with, it is deep you understand this operational system. The major part of blue teams usually don't try to understand the operational system. And then try to go dive into. And this slide is just a visual reminder of the same message: delivery, execution, defenses, all connected. You don't have to remember every technical detail, but try to remember the flow, HTML, loader, syscall, behavior detection. And then when you see an HTML attachment, now I hope you think twice about what may be writing behind it. That's it from me. Thank you so much for your time and attention, and let's go to Q&A session. That's really a great question. For example, in this case, I'm used the commercial ADR or XDR. Okay, that's okay. The main goal, and then you need to focus on focus on the better configuration. You know, sometimes when you don't UXDR, sometimes it's really good, but sometimes you don't have the better configurations, you don't focus on hardening configurations, and then you basically create one environment that can be a poor, you know, and then you can focus on child process and stuff like that. You can block child process, and then it's not only from Microsoft XDR, but from another XDR, but thinking that this is not sufficiency. You buy one commercial ADR and put in place. You need to make many configurations so that things like that doesn't work. It depends on what your main goal. Sometimes you need to create your own tools. Okay, of course you have a many tools. If you search in a GitHub, you can find many ways or many tools that's already was constructed or built to bypass or to use this type of technique. But usually I like to buy myself, to create by myself my own tools, but have many others available, and I can share. If you connect with me on LinkedIn, I can share some tools that are available on GitHub. You have many layers to, and then you have many ways to try to avoid this type of technique. And then, for example, use next generation firewalls that have an option to look for application, the application level. Okay, and then you can easily can avoid this type of attack. Of course, you need to configure it with sometimes the vendors recommendations and with the best practices. But however, if I'm look for the landscape, you can see many vendors that already have or firewalls that provide next generation solutions to avoid this type of attacks. Okay, sometimes you can use, for example, because okay, I'm here in my lab. I don't use, for example, any encryption here. I just use HTTP, pure HTTP. But for example, usually attackers use TLS or SSL, and then you need to implement things like SSL inspection and stuff like that to try to block this type of technique. Okay, let me see view detection from. Yeah, okay. Usually, like I said before, EDR usually use the behavior to detect. Okay, you need to be sneaky. You need to think, and then, like I said, that's really important so that you can understand how operational systems work. If you really understand how operational systems work, you can hook to another process, the legitimate process. Okay, you can find legitimate process, let's say explorer.exe, notepad.exe, and you can inject that. And then usually if you use this type of techniques, you can avoid detections. But if you try to, for example, just to inject in process that really, for example, SVC hosts, usually attackers try to inject directly inside this type of process, and this process, this widely, usually EDRs widely love to look for this type of process, and then try to avoid this common process. Okay, try to for example, try to inject this type of techniques inside of process that are not looked for EDR for many times. That's really a great question. I'm not using here encryption. I'm use basically I used the one basically the one legitimate process, and I inject my legitimate process. I inject my shell code inside this legitimate process. Okay, and then because of that, the Windows, the Microsoft Defender cannot detect my payload. But of course, you can improve, okay, your payload using Shore or using another encryption techniques. And then if you improve these techniques, of course, you be really harder to EDR and XDR to detect them. And then in my case, I just used here one normal shell code, and I put inside of my in my loader, and just inject using a normal anti-DLL process, and then that's it. But if you want to improve your technique, you can, for example, use some techniques using encryptions. The red teams right now, okay, it's more harder to balance, to create this balance, because right now you have a lot of, usually this is not a new concept, but a deep defense that you can use this deep defense. And then I think that, for example, when are you working with a red team role, you need to focus on right now in try to bypass detections, and try to stay sneaky, try to don't make noise. Okay, and then because right now you have blue teams have a lot of tools, have a lot of sensors to detect, for example, Nmap scanners to detect a lot of type of things, and sometimes isolate one virtual machine or stuff like that. Just if you, for example, use the Nmap script with a brute force command. And then I think that the main goal here is try to understand first the environment before any attack. Okay, try to create a good reconnaissance, try to understand the environment, and after that okay, create the weaponization. Okay, create your tools, okay, based on what you detected before. Okay, let me try to explain. If you detected, for example, that your customer or if your businesses use, for example, okay, CrowdStrike, for example, try to understand how CrowdStrikes work. Try to look for what the process the CrowdStrike are looking more, and try to create this strategy to try to avoid detection. I think this is thinking and evasion. I think this is my my recommendation, let's say. Yeah, for sure. That's really interesting, because right now the attackers are focusing more on malware labs, try to understand how to bypass things, because right now you have a lot of tools, a lot of security measures that you can put in place. And then right now the attackers are shifting, living off the land. This term is that's really are being used all the time, usually because of this not EDR maturity, but XDR as well. And then, but this is not it's not a black box, you know. You can, okay, it's like I said before, it's like a cat and mouse run, you know. And then okay, but I think if you wanna work with red teaming, you need to understand how to bypass things. Yeah, to answer this question, okay, that's interesting. But to answer this question, you need to have both teams. You need to have blue teams working. You need to have a red team working together. And then, okay, this is basically this is not a fight between blue team and red team. People right now need to understand that it's the same business, the same team. It's not the same team, but the same people that work to the same business. And then to really take this feedback, you need to the blue teams needed to okay, after these tests, you needed to compare, okay, the result at the last bypass with the new bypass, with sometimes with CM correlations, with new alerts and stuff like that. But you needed to have these both teams working hardly to really to create this balance between blue teams and red team. Yeah, right now a lot of people talking about AI, use AI agents to bypass, etc. Right now, I think that the future it's more you can use AI to help you to create your own tools, to create your own ways to encrypt the traffic and encrypt your payloads. I think the future it's basically the balance between okay, AI and okay, let's say AI and custom tools and manual techniques. I think that will be the future. For EDR evasions, after that, for example, after when I compromise a system, usually the attacker try to get credentials, try to do privilege escalations and stuff like that. And if the attackers did a good EDR evasion, you probably can't see, you can see logs, and like many people say, no log, no crimes, of course, but that's really important. You follow step after the EDR evasion, okay? Look for logs, for example, to new process that was created, usually in servers that, for example, servers that has a account for example, that are joined in domains. That's really important, so that you look for this type of logs, create a new process, users being added in new groups. Okay, that's really interesting to look for type of logs, but basically that's really hard to find one specifically log that you can see. Okay, you can look for this log because this log from IDR, because if the attacker could bypass your ADR, antivirus, or XDR, you don't have a log. But you need to have a concern after that. You need to concern, for example, with Mimikatz executions, new process creations, and stuff like that. I think this need to be observed with blue teams, and usually blue teams use secure operation centers with a CIEM and things like that. You need to have to create a correlation of many logs to try to understand mainly the creations of new process or child process. Yeah, thank you for that. I really appreciate your time. This is my second time here on Cyber Talks. I'm official instructor at the ECCU as well. And keep learning, keep trying inside the labs. That's really important. Right now you have a lot of tools, a lot of techniques. You can use AI to learn, and then enjoy the process. I think that's interesting. This is not easy. This type of research, it's not easy, of course. It's I confess that's not easy, but keep learning, keep trying, and don't give up.